Okay, physics review test solution. Um, I started going over this in class today. Told them I would post this for the remote students, and here we go. So, which paragraph represents the same motion of an object? Oh, before I continue, this probably be in two parts. A couple 20-minute videos likely. So, same motion of an object. Displacement versus time and velocity versus time. Usually we look at these vertically, right? Where it's x versus t, v versus t, and a versus t, which most people actually prefer to look at them vertically. But these are going across horizontally, which sometimes they'll do. Well, if position versus time is curved, velocity versus time is linear, acceleration versus time is flat. You may remember that. Curved, linear, flat, 0, 0. All right? So if we have a linear displacement versus time, velocity versus time needs to be flat. But the problem with this one is this is a positive slope. So the slope of displacement versus time, this is the same as position versus time. The slope of displacement versus time tells us what's going on with the velocity. So this is a positive constant slope, so this should be a positive constant velocity. That one's not it. All right, displacement versus time, this is a constant negative slope, so that should be a constant negative velocity. Well, this is a changing velocity. That's not it. All right, this one here, we have a curve, displacement versus time, so velocity versus time should be linear, some sort of linear, meaning it should be an angled line. So it's not a constant velocity. This can't be it. It's got to be this one, but let's just take a look at this one. This is actually the example I drew. We have a increasing slope, meaning if we drew some tangent lines here or used our slopeometer, we see that the slope is getting steeper, therefore the velocity is increasing. The velocity is getting more positive as time goes on. The answer is D. All right, number 2, a skier starting from rest, straight down a slope 50 meters long in 5 seconds. So starts from rest, that means the initial is 0 meters per second. Straight down a slope 50 meters long, so that's delta x is 50 meters. Time is 5 seconds, that's t. What is the magnitude of the acceleration of the skier? That's A we're looking for. So I consult my equation sheet here. All right, so I want to find one that has A in it. It has delta x, t, v initial. All right, so t is the key here, right? It's usually one of these two to solve for these variables, right? If it's a big problem. Sometimes it's just one of these short ones, but it's often one of these two, the v squared equation or El Grande. Now, sometimes v squared equation is called a timeless equation. So if you don't know the time, you're pretty much always using this equation. But since we're given the time, let's see if we can use this. So delta x we know, a we don't know, t we know, v initial we know, and t we know. So a is the only unknown variable in this formula. That's the right one to use. So delta x equals 1/2 at squared plus v initial t. Now you don't have to show all your work on a multiple choice question, but you know, sometimes if you treat them like a short answer question, you can better ensure that you're going to get the right answer. So 50 meters for delta x. I'm not going to put the units in right now because they're listed up here. This isn't a short answer question. So 1/2 of a, which is unknown, times 5 seconds squared. All right. And this term is just 0 because v initial is 0. The term just goes away. So we have multiplied both sides by 2. All right. Bam, bam. Divide both sides by 25. That's 5 squared. All right. So 2 times 50 is over 25. That's 100 over 25. That's going to be 4 meters per second squared. Great. Diagram below represents the relationship between velocity and time of travel for 4 cars, A, B, C, and D, in straight line motion. Which car has the greatest acceleration during the interval 10 to 15 seconds? So that's from here to here. So acceleration is related to a velocity versus time graph because it's the slope of of v versus t. Or acceleration is delta v over t, rise over run. This is your time. They all have the same run of 5 seconds. Which one has the greatest change in velocity? Well, in this time error, clearly d is starting off at rest and going up to whatever the velocity of a is. A doesn't change. A actually has no acceleration. B only goes up a little bit in that 5 seconds. D goes up a little bit more, or C goes up a little more, but D most definitely goes up the most in that time. So the answer is D. Baseball player throws the ball horizontally. Which statement best describes the ball's motion after it's thrown? All right, so projectile motion. Baseball thrower threw a ball. All right, ball's flying through the air. It's going to be in an arced path, right? It's going to kind of fall down to the ground. And the most important thing to remember about projectile motion is basically the answer to this question. The x velocity, or the horizontal velocity of the object, doesn't change. The whole time this ball is in the air, it's moving forward at whatever speed it was thrown. However, as it goes forward, it's going to fall down, and it's going to gain velocity in the vertical direction. So the horizontal velocity is constant, the vertical velocity is increasing. So vertical speed remains the same, that's true. Or no, that's not true. See, that's the whole thing with these questions, is reading them correctly, right? Sometimes that's half the battle with all these types of multiple choice questions, just reading them correctly. So that's not it. Vertical speed does not remain the same. The vertical speed increases. So the vertical speed increases, the horizontal speed increases. No, the horizontal speed does not increase because there's no force propelling it forward. It was pushed forward. Now the only force acting is gravity to pull it down. Its vertical speed increases, horizontal speed remains the same. That looks good. Let's just, vertical speed remains the same. That's incorrect. So it's C. All right, so again, your version of this may have been different, but that's okay. They're all the same questions, might be in different order, different answer choices, etc. Which vector diagram best represents a cart slowing down as it travels to the right? So something's traveling to the right, all right, on a horizontal surface. And our options here, the way I'm going to think about this is, Fn and Fg, they are going to cancel out. Something's traveling to the right, which might make you think that the force going to the right is bigger. But what you got to remember here is the essence of Newton's second law. Newton's second law says the acceleration of an object is equal to the net force acting on an object divided by its mass, or the net force acting on an object is equal to the object's mass times whatever the acceleration of the object is. So if something's moving to the right and slowing down, that means something's pulling it backwards, right? That means the net force must be opposite the direction of motion. So when something's slowing down, there's always a force kind of pulling it backwards. If something's speeding up, there's a force pushing it forwards. So in this case, whatever force is going to the left, backwards, must be bigger, right? Because this one would be accelerating this way, right? Direction of the net force is direction of acceleration. This one would be accelerating that way. This is probably our right answer. This one, there's acceleration is 0. This one, the acceleration is also 0 because they're balanced, right? Here we have a little bit of net force left over to go backwards. So the friction's bigger than the applied force. This object would be slowing down. The answer is B. All right, literally everybody got this one wrong on the test, and I don't blame you. You really fell for a trap. The fact that everybody got that wrong, I'm probably going to give you a bonus point for it. Mark it right for everybody. Something, you missed something along the way, or something didn't stick when we talked about this previously. So when a 12 Newton horizontal force is applied to a box on a horizontal tabletop, the box remains at rest. The force of static friction acting on the box is, so we have a box, there's some sort of force pulling on it with 12 newtons. Well, that force doesn't cause it to move. It doesn't cause it to accelerate. So I asked the class, okay, who said it was A? Oh, actually it was the way I asked, it actually was C was A, and it was jumbled up differently here. But I asked, okay, who said it was C? Nobody raised their hand. Then I said, okay, who said it was D? Most of the class raises their hand. Who said it was B? One kid raises his hand. And then who said it was A? Nobody raises their hand. So everyone knew there had to be some sort of frictional force. But most people said it was greater than 12 newtons. And I said, okay, so if the force of friction is greater than 12 newtons, let's say it's 13 newtons. What would that make the net force? Oh, that would make the net force negative 1 newton. And if the net force was negative 1 newton, this object would have to be accelerating to the left. So somehow, if the force of friction is greater than 12 newtons, friction itself would somehow be accelerating this object backwards? That doesn't make sense. Friction can't do that. Friction is not an active force, right? It's a passive force, meaning it's a responsive force. It occurs because of some externally applied force. So this isn't going to work here. That can't be the answer. It can't be greater than 12. So then somebody in the class said, ah, ha, 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 it's between 0 and 12. So I said, okay, let's say it's 6 newtons. Okay, if it's 6 newtons, what's the net force? Well, the net force would be positive 6. It would be to the right 6. So somehow there would be a net force to the right that would have to cause it to accelerate to the right. So it wouldn't be at rest. If a box is at rest or moving at a constant velocity, all the forces must be balanced. All right, and that person's explanation as to the 0 to 12, they said, well, I figured there must be some other force acting that's not mentioned. You can't make that assumption. That could be an explanation, but it's not the right one. The right one is C. The force of friction must be 12 newtons. It has to be equal to the applied force to keep everything balanced. Really great question right there. I love that question. I usually test on that multiple times per year. A great question. Very hard. Another thing people fall into is the trap of, okay, wait a minute. I got to go to this table, right? It's a box on a surface, so that's probably wood on wood, so I'm going to use this coefficient, 0.42, and I'm going to try to multiply that by 12. No, that's crazy. You don't know the mass of this. You don't know the normal force. You can't calculate the force of friction if you don't know the mass or the materials. It doesn't tell you the materials. Don't try using that coefficients of friction unless it explicitly states what the materials are. All right, number 7. A 1.5 kilogram lab car is accelerated uniformly from rest to a speed of 2 meters per second in 0.5 seconds. What's the magnitude of the force producing this acceleration? All right, F net equals ma. F net equals ma. Good stuff. F net equals ma. So, we'll just put it in here. F net equals ma. All right. A is delta V over T. So really it's m delta V over T. And then we just plug in the values. So it's 1.5 kilograms. That's your mass. From rest to a speed, that's your V final. Your delta V is plus 2.0 meters per second. I'm not going to put the units in our little scrap calculation here. And the time is 0.05 seconds. 1.5 times 2 is like 3. 3 divided by 0.5 is 6 newtons. Great stuff. Number 8, diagram below represents a 0.4 kilogram stone attached to a string. The stone is moving at a constant speed of 4 meters per second in a horizontal circle having a radius of 0.8 meters. All right, so that's good. What is the magnitude of the centripetal acceleration of the stone? All right, so this is way down at the bottom here. All right, it says F net C equals mass times centripetal acceleration, which equals mass times velocity squared over r. So that means v squared over r is the centripetal acceleration. They give you the mass in here, so AC equals v squared over r. That equals 4 meters per second squared divided by 0.80 meters. So let's see what we get here. Should be 16 divided by 0.8, that should be 20. So 4 squared divided by 0.8 is 20 meters per second. Now, let's see, if I multiply that by 0.4 kilograms, what do I get? I get 8. Okay, so they don't give you the other wrong answer. What a lot of people do is they don't differentiate between centripetal acceleration and centripetal force. All right? And remember, centripetal force is not some magical force that appears because something's moving in a circle. It's the force that is causing an object to move in the circle. In this case, that force is a force of tension. In the case of a satellite in orbit around the Earth, that would be the force of gravity. You rounding the corner in your car, it's a normal force, a frictional force, force from the seatbelt. All that stuff combined pulls you in a circle when you're around the corner in your car. All right, so 25 kilogram space probe fell freely with an acceleration of 2 meters per second squared just before it landed on a distant planet. What is the weight of the space probe on that planet? Weight is the magnitude of the force of gravity. Weight and force of gravity. Weight is in newtons, mg. Weight. Mass is mass, weight is weight. So you got to be careful there. So this is in newtons. So it's a 25 kilogram object. That's not the weight. It's not 25 newtons. It's mg. So it's 25 kilograms. Well, what's g? G is often called acceleration due to gravity, or we have called it gravitational field strength. So on Earth, G is 9.8 newtons per kilogram, or 9.8 meters per second squared. When it's newtons per kilogram, we call it gravitational field strength. When you replace the newtons per kilogram with meters per second squared, we call it acceleration due to gravity. And this is, acceleration due to gravity is equal to that because if you draw a force diagram for an object, some mass, you say, okay, what force is acting on it? Well, mg is acting on it. Okay, so what's the acceleration? Well, F net equals ma, right? F net is just the force of gravity, so mg has to equal ma, the m's cancel, you get that the acceleration is equal in magnitude to g. So in this case, the acceleration due to gravity is 2.0 meters per second squared. So the answer is 50 newtons. Fun stuff. All right, number 10 was actually one of the ones that was on the review sheets, and I accidentally put it on here, so hopefully most of you got this right. We had gone over it in class, and you know, most people thought this unit was pretty easy. So the diagram below shows a 4 kilogram cart moving to the right and a 6 kilogram cart moving to the left. When the two carts collide, they lock together. The magnitude of the total momentum of the two-cart system after the collision is, well, conservation of momentum says the momentum after the collision is just equal to whatever the momentum was before the collision. So the momentum before the collision, you have to keep in account the signs, right? So 3 times 4 is plus 12 units of momentum on this one. 3 times 6, negative 18 units of momentum on this one. So this one having negative 18 units of momentum is because it's moving to the left in the negative direction. Note they didn't put the signs on here, right? They show you the vector to tell you the direction. They literally show you the vector. We have to put the signs on it when we do the calculation. So the total momentum here is negative 18 plus 12. It's negative 6. So it says the magnitude of the total momentum. So in fact, these two things are going to lock together and move to the left. They're going to have a negative momentum after the collision because this one's more mass, right? So, and they're moving the same speed. So this one's going to win the collision. All right, so the answer is A. There's no negative signs here. One student had said it's 12 plus 18, so it's 30. That's a trap. It's a trap. You got to keep in count the fact that this one's negative. It's a vector sum. Vector sums, you must include the signs. 0, somebody said, because we had this one example in class that they got confused with where they come together at the same speed and they stop and they stick together and they don't move after they hit. They just hit and stop. That's because they had the same mass as well. So the total momentum before the collision was 0. So when they stick together, the total momentum has to be 0. They can't move. All right, number 11, in the diagram below, a 60 kilogram roller skater exerts a 10 Newton force on a 30 kilogram roller skater for 2 seconds. What is the magnitude of the impulse applied to the 30 kilogram roller skater? All right, so impulse equals change in momentum. Force times time equals m delta v. impulse is force times time, change of momentum is m delta v, but there is also kind of this like cross multiplication thing where these two equations are this, impulse. If you know the mass and the change of velocity, you can calculate the impulse given to the object from that. So impulse results in a change of momentum. So impulse is technically different than the change in momentum. Impulse causes the change in momentum. You give an impulse to something by applying a force to it for a certain amount of time, which causes its velocity to change, which causes its momentum to change. All right, so the impulse here, all right, so we know the force, and we know the length of time, so it's simply the force times the time here. So it's force times time, 10 times 0.2, so that's 2 Newton second. We could then find the change in velocity, which, wasn't asked, but I suppose you could do that. This is about as far as we got in class today, so I think I'm going to pause this video here, especially since the bell just rang, and I will finish with the last 4 multiple choice and the short answers in the second video. All right, so I'll upload this and hopefully this will help you study for the final exam.